Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers iterative sequences. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognize command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up. It will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 15. Work out an approximate solution to x cubed plus 3x minus 1 equals 0 using iteration. So xn plus 1, the next term in x is equal to 1 over xn squared, the last term in x squared, plus 3. And we start with xy is equal to 1. Okay, so with these iterative methods, we keep taking a value and resubstituting it back into the equation until the answer settles down and we get a solution. So x1 equals 1, so then x2 is going to be 1 over our x1 value squared plus 3. Okay, so 1 over 1 squared is 1 plus 3 is 1/4, isn't it? And then we keep doing that. We're going to feed 1/4 back into here to get x3. So x3 is going to be 1 over 1/4 squared plus 3. Now I could probably do that in my head still, but it's easier to do it with the calculator. Now, rather than typing these all in individually, we're going to use the answer key to refeed the answer straight back into the calculation. So if I just put in the number 1 and press equals, that will store the number 1 as the last calculated value, and I can use it using the answer key. And then my next calculation I'm going to do is going to be 1 divided by, then I can use my answer key, which would currently be 1 squared plus 3. And then if I press equals, it should give me my quarter like it did last time when I worked it out. So all I need to do now is press equals again, and it will feed my 0.25 back in the equation and give me the next answer, which is 0.32. I'm going to write these down to 3 decimal places, one more than they're asking me to, so I can see when it's settled down. So this is 0.327. Okay, and then if I want x4, I just need to press the equal button again. That gives me 0.322 to 3 decimal places. And again, x5, you can see it's beginning to settle down now, is 322 again. Okay, and if I press it again, you can see it stays at being 322, 322. So it's kind of settled down now. Every time I press equals, I'm just getting the same answer now. So rounding that off to 2 decimal places, my answer is going to be 0.32. Question 16. A sequence of numbers is formed by the iterative process un plus 1 is equal to 4 over un minus 1, where u1 is equal to 9. Okay, and we need to work out the values of u2 and u3. Now what we've got here, what this is a term-to-term rule given algebraically, isn't it? Okay, so our second term, our next term in the sequence, we find the next term in the sequence by taking 4 and dividing it by the previous term in the sequence, subtract 1. Okay, so we know, and we've been given, the first term of this sequence is u1, and that is equal to 9. So we know that u1 is 9. Now u2 is going to be 4 divided by u1, which is minus 1, which is 4 over 9 minus 1. 9 minus 1 is 8. 4 divided by 8, that's the same thing as a half, isn't it? It's just going to be a half, or 0.5. Okay, so u2 is a half. u3 we're going to get by taking 4 and dividing it by our previous term, u2, subtract 1, which is 4 divided by a half, subtract 1. Okay, so what's a half subtract 1? A half subtract 1 is minus a half. And what's 4 divided by minus a half? So 4 divided by minus a half, what we can do is we can take that fraction, keep change flip, isn't it? So that's the same thing as 4 times by minus 2 over 1 then, isn't it? Okay, which is negative 8. Okay, so u3 is negative 8, u2 is a half. Question 16a. Use the iteration formula xn plus 1 equals the cube root of 10 minus 2 lots of xn to find the values of x1, x2 and x3. Start with x0 equals 2. Okay, so an iteration formula gives you the next term in the sequence if you know the previous one. So this is the symbol for the next term and this is the symbol for the previous term, isn't it? Now we know our first term is 2, so that's going to be our initial term for xn. Okay, so and we can use x0 to generate x1 using this formula. So x1 is going to be the cube. It's going to be the cube root of 10 minus 2 lots of our value for x0, which is 2. Okay. So right, now I'm going to type that into the calculator very carefully and in a particular way, so I can just type one function in once and keep reusing it to find all my other values. Okay, so what I'm going to do first is I'm going to press 2 and then I'm going to press equals. So what that will do is it will make 2 my last calculated value. Now the reason why that's important is because then I'm going to type in the function that I want to find. So shift to find the cube root 10 minus 2 lots of the answer, so the last calculated value that I made. Now the last calculated value was a 2, so this is going to sub in the value 2 into that formula and then work out the new one. Okay, so that gives me 1.817120.593. Okay, now I'm not going to write down all the digits, I'm just going to write down I think 4, so 1.817. Okay, so I'm just going to round it off to 4 significant figures. x2, now the reason why I did it that way is because now if I just press equals, it will work out the next one for me. Okay, so I didn't have to type it in again because I had the new answer 1.817 as the last calculated value. If I press equals again, it's going to sub that one back in and I'm going to get the next one, 1.853 and change. Okay, and then we're just going to press equals again and I'm going to get 1.846 and change. Okay, moving on to part B. The values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form x cubed plus ax plus b equals 0, where a and b are integers. Find the value of a and the value of b. Now remember, we were given the expression xn plus 1 was equal to the cube root of 10 minus 2xn. Right, now if I want to actually form this into an equation, all I need to do really is replace xn plus 1 with just x and replace xn with just x and then rearrange. Okay, so let's first off try to get rid of that cube root on the right by cubing both sides. If I cube both sides, then on the left I'm going to get x cubed, and on the right the x cubed is going to cancel with the cube root and that's going to leave me with 10 minus 2x. Okay, and then collecting everything on the left hand side by adding 2x and subtracting 10, I'm going to get x cubed plus 2x minus 10 is equal to 0. So then comparing that with what I've got up there, then a then is going to be this coefficient of x here, which is 2, and b is going to be this this constant on the end, which is negative 10. So a is 2 and b is negative 10. Okay. Question 17. A sequence of numbers is formed by the iterative process un plus 1 equals 20 over un plus 3, where u1 is 1. Work out u3, circle your answer. Okay. So we're given that u1 equals 1, then u2 then, the next term in the sequence, is going to be 20 over the value of u1, which is 1 plus 3. Okay. So what's 20 over 1 plus 3? 1 plus 3 is 4. 20 divided by 4, that's 5. Okay, so then u3 is going to be 20 over the value of u2, which was 5 plus 3. So 20 over 5 plus 3. 5 plus 3 is 8. 20 over 8. That's the same thing as 5 over 2, isn't it? It's that one there. Okay, we've got some iteration here then. So our next term in x, which is xn plus 1, is equal to 4 minus 2 over our last term in x, xn, all squared. So to work out an approximation solution to x equals 4 minus 2 over x squared. So we're going to start with x1 is equal to 1 and feed that into this expression and then work through it. I'm going to have to keep going until our answer settles down into a kind of a consistent answer. Okay, so we know that x1 is equal to 1, so then x2, our next term, is going to be 4 subtract 2 lots of x1, 1 squared. So 1 squared is 1, 2 divided by 1 is 2, and 4 subtract 2 is 2, so x2 is equal to 2. So then we just keep going. So what's x3? x3 is going to be 4 minus 2 over 2 squared, our previous term squared. So 2 squared is 4, 2 over 4 is a half, 4 subtract a half is 3.5. So that's our x3 term. x4 we're going to get by, again, we're just going to keep subbing back in, 2 over 3.5. I'm going to use a calculator now, 3.5 squared. Now, actually, with clever use of our answer key on a calculator, we should be able to feed in this answer very quickly, so we don't have to keep typing it in over and over again. If I press 1 equals first off, that will store the number 1 as my last calculated answer. And then if I type in 4 subtract 2 divided by answer squared, that will take my last calculated value, which was 1, and feed it into this expression. So when I press equals, you can see I've got the answer 2, which is what I calculated earlier. But the clever thing is now 2 is now the stored value. So if I just press the equal button again, it will feed 2 into that same expression and then recalculate it. So that gives me my 3.5. So to make this easier on myself, and now all I have to keep doing is just press equals, and that will keep giving me the next one. So the next one is 3.84 to 2 decimal places. Let's just, actually I might write it to 3dp to start with so we can see if it's settling down. Okay, so then x5 is going to be 4 minus 2 lots of 3.837 all squared. But I just need to press the equal button. That gives me 3.864, so it's still not quite settled down. So x6 is going to be 4 minus 2 lots of 3.864 all squared, and that is equal to 3.866. So that's going to round up, isn't it? If I round off to 2 decimal places, that's going to be 3.867. So it's still not quite settled down. Let's just do another one. X7 is 3.866 all squared. And you can see now that this time it kind of just settles down on 866 again. Okay, and if I keep pressing it a few more times, you can see that it just stays like that. Okay, so then rounding that off to 2 decimal places, my final answer is going to be 3.87. That's 3.87 to 2dp. Question 22. An approximate solution to an equation is found using the iterative formula xn plus 1 is equal to x to the n all cubed minus 2 all divided by 10, where x1 is equal to minus 1. Part A says work out the values of x2 and x3. Okay, well, this is our iterative formula here, xn plus 1, and what we do is we sub in our last value into the formula to get our next value. So if x1 is equal to minus 1, like it says in the question, then x2 then is going to be my x1 value, which is minus 1, all cubed, subtract 2, and then divided by 10, which is what? It is negative 1 cubed is negative 1, subtract 2 is negative 3, divided by 10 is negative 0.3 then, isn't it? Right, now x3 then I'm going to get by taking minus 0.3 and cubing it and then subtracting 2 and divide by 10. Now, I'm not going to be able to do that in my head. And I think what I'm going to do is I'm going to show you a trick with the calculator with these sorts of things. Okay, so what I'm going to do is I'm going to start with my first value, x1 equals minus 1. I'm just going to type that into the calculator. So negative 1, and then I'm going to press the equal button. What that will do is it will store negative 1 as the last calculated value. Okay, so now what I'm going to do is then set up a calculation involving that answer so I can keep feeding it back in on itself. So I'm going to type open bracket answer cubed minus 2 close bracket divide by 10. Now what that will do is will take my last calculated value of minus 1 and will feed it and it will appear there where the answer is. So minus 1 cubed take away 2 divided by 10. That gives me my x2 value. You can see minus 0.3. But the clever thing is, if I then press the equal button again, now that answer then will get fed into that same calculation and it will give me my next value, the x3 value. So if I press equals again, you can see that comes out to be minus 0.2027. So that is equal to, oops, change pen, minus 0.2027. So that was my x2 and my x3 value, minus 0.3 and minus 0.2027. And the next part says, look, work out the solution to 5 decimal places. So I just need to keep generating more and more values, and it should start homing in on the true answer as we move on. So that's x3 was that one. So let's press the equal button again on the calculator, and that will feed my x3 value back into the iterative formula, and it will give me my x4 value. So x4 should be that one there. So x4 equals negative 20083. 20083. Now it wants me to show it's settling down on 5 decimal places, so I'm going to write down the first 6 for now, and then let's generate x5. So press the equal button again. You can see that gives me minus 0.200810. Okay, so you can see it's kind of settled down up to about here so far, to 4 decimal places. Let's do another one. Now I'm getting x6 which is minus 0.2008 Okay, so again, it's not quite settled yet, is it? It's still only settled as far as here. The last two digits are still moving around. So let's try one more. Okay, seems to have kind of settled now all the way. So now I've got x7. I've got minus 0.200809 still. Okay, and if I keep pressing the equals sign button after that, you can see it doesn't change after that. It keeps coming up with the same answer. So you can see the number pattern is kind of settled down all the way down to here, which is to 6 decimal places. We only need to quote this to 5. So really we should round off at this point. And because it's a 9, I'm going to round up. So my final answer I'm going to give is minus 0.20081. Question 23. A sequence of numbers is formed by the iterative process un plus 1 is equal to 3 over un plus 1, where u1 is equal to 4. Work out the values of u2 and u3. Right, just before we get going, just note that this un plus 1 is not the same thing as this thing here, un plus 1. This un plus 1 is 3 divided by un plus 1. Okay, so we take our previous value un, we add 1 to it, and we divide 3 by that number, and that will give us our new value un plus 1. So if I've got u1 is equal to 4, then u2, the next value, is going to be 3 divided by u1, 4, plus 1. Okay, so my un here is 4, u1, and my u2 is my un plus 1. Okay, so I've got 3 over 4 plus 1, which counts, well, simplifies down to 3/5. And then my u3 then, my third term, is going to be 3 divided by my second term, 3/5 plus 1. Now that is equal to, well, what's 3/5 plus 1? 1 is 5/5. So 3/5 plus 5/5 is 8/5. So I've got 3 divided by 8/5. Now dividing by a fraction is the same as multiplying by the flipped fraction. So flipping over 8/5 to 5/8 and multiplying instead, that tells me that 3 times 5/8 is 15 over 8. So my u2 term then is 3 over 5, 3/5, and my u3 term is 15 over 8. Question 30. A sphere has radius r centimeters. An approximate value of r can be found using the iterative formula rn plus 1 equals the root of 239 divided by rn. The starting value is r1 is equal to 7. Work out the values of r2 and r3. Okay, so what I like to do with these is I like to type in the first value into the calculator and then press equal, so it's the last stored value. Okay, and then I'm going to get the next value by taking the square root of 239 divided by rn, which I'm going to use the answer key. So basically the last calculated value is going to come back and go into there. Okay, so R1 we know is 7, then R2 is going to be the root of 239 over 7, and I'm just going to press my answer key and find out what that is. That's equal to 5.843. I'm just going to write it down to 4 significant figures for now. 5.843, and then R3 we're going to get, all I need to do now is I'm going to write it out, so that's going to be 289 over 5.843, but because we the way we set it up on the calculator, all I have to do is press the equal button again, and it's going to feed in R2 into the formula, and it's going to give me R3 straight away. So that's 6.395, and again we're just going to write down the first 4 significant figures for now. So that's 6395. Okay, so we're done with that. Part B says continue the iteration to work out the radius to 1 decimal place. So basically we're just going to have to keep on finding more and more values until it settles down on the first decimal place and we start getting the same answer over and over again. So we've already got R3, so let's go on to find R4. Now again, I'm just going to press the equal button. That's going to feed in my R3 value and give me the R4 value. And again, I'm just going to write down the first 4 significant figures, 6.113, and I'm going to keep going until it settles down. So then the next one, R5, is equal to 6.253, and then R6 is equals 6.183. Still jumping around a little bit and wait until it settles down. R7 equals 6.218. Still bibbling between 1 and 2. Next one, R8 equals 6.200. R9 equals 6.209. And R10 is equal to 6.2. It seems to have settled now, doesn't it? 204. So the last digit is still kind of resolving itself. And then I've got R11 is 6.207. And then the next one. And if I keep pressing it now, I think I'm just going to keep pressing it now. Can you see it just kind of resolves to 6, goes down to 6.2058. Just going to round off to 6.206. That's where it kind of settles to. Okay, so then you can see that to 1 significant figure actually settled pretty quickly. It settled on the 6 from the first, well, from the second, from R3, didn't it? And then it started being 6. But it didn't really settle on the second decimal place until we got to R7, R8, and then it stayed being 2. Okay, and then you can see then we started getting the third decimal, the third significant figure there, and it took a little bit while longer for the 4th digit to settle down. But we just want to know what the radius is to 1 decimal place, so that is equal to, so the radius is equal to 6.2 to 1 dp. Okay. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.